Let's now learn about the increasing-decreasing test and walk through some examples. The increasing-decreasing test is used to find where a function is increasing or decreasing. In this graph, we have the function y is equal to f of x, and we're going to look at where it is increasing and decreasing. If f prime of x is greater than 0, our function has a positive slope and it is increasing. If f prime of x is less than 0, such as on the left-hand side of our graph, the function has a negative slope and it is decreasing. Let's now walk through some examples. In this first set of examples, we are going to find the intervals on which f of x is increasing or decreasing. Just to make things easier, I've written down 3 steps that we can follow. We're first going to find the critical numbers, and then we're going to find the value of f prime to the left and right of each of those critical numbers. And then step 3, we can just write down the intervals for increasing, that is when f prime is greater than 0, or decreasing when f prime is less than 0. Let's look at our first example. We're given the function f of x is equal to 3x to the 4th minus 4x cubed minus 12x squared plus 5. The first thing that we're going to do is find the critical numbers, so we're going to start by taking the derivative. F prime of x is equal to 12x cubed minus 12x squared minus 24x. To find the critical numbers, we set that equal to 0. It looks like we can factor out a 12x, and then we're left with x squared minus x minus 2. We can then factor our quadratic. Let's see, we can factor it as x plus 1, and then x minus 2. And then we set all 3 of those terms equal to 0, and we get x is equal to 0, minus 1, and 2. Our second step is to find the values of f prime to the left and right of these 3 numbers. I'm going to highlight f prime because that is what we're going to have to be looking at. Let's now make a number line. This is going to be x, and we're going to put our critical points on it. We have -1, we have 0, and then we have 2. The spacing doesn't matter at all. We're now going to be looking at the value of f prime to the left and right of these 3 points. When you're working with a polynomial, the region to the left and the region to the right of all the critical points is determined by the leading term of f prime. The leading term has an x cubed in it, so it is going to be negative when x is negative, and it's going to be positive when x is positive. That just makes it a little bit easier. Now what we have to do is look at values between -1 and 0, and then between 0 and 2. For this part, I think it's easiest if we look at the factored form of f prime, which is this part right here. Over here on the right, I am going to make a table. I'm going to put down x, and then I'm going to put all of the factors that I highlighted in orange. So we have x, x plus 1, and x minus 2. And we are going to be looking to see if those factors are positive or negative. The point that I'm going to choose between -1 and 0 is -1/2. And then -1/2 is negative. -1/2 plus 1 is positive. And then -1/2 minus 2 is negative. Now let's pick a point between 0 and 2. I think the easiest point is 1. So 1 is positive, 1 plus 1 is positive, and then 1 minus 2 is negative. In the region between -1 and 0, we have a negative times a positive times a negative, so that's going to give us a positive. And then in the region between 0 and 2, we have a positive, positive, and a negative, so that is going to be negative. I think before we go to step 3 and write down the intervals for increasing or decreasing, I've always found that it helps to draw an increasing or a decreasing line in each interval. So in our leftmost interval, we have decreasing, then we have increasing, decreasing, and increasing. Now we can just write down the intervals for increasing and decreasing. Our function is decreasing on the interval from -infinity to -1 and on the interval from 0 to 2. And then our function is increasing on the interval from -1 to 0, and then our rightmost interval from 2 to infinity. And we'll go ahead and we'll highlight those answers. Before we go on to the next problem, let's look up here on the right at our graph. Our critical points are the points right here, here, and here. They're the points where our function changes from increasing to decreasing or vice versa. And you can see on the graph that our function is decreasing in this interval and in this interval, and then it's increasing in this interval and in that interval, just like we calculated. Now let's look at our second example. We're given the function f of x is equal to 2 plus the quantity x minus 5 cubed. Just like we did with our first example, we are going to start by taking the derivative. We have f prime at x is equal to 3 times x minus 5 squared, and then the derivative of what's inside is just 1. And we set that equal to 0, and we get a value x is equal to 5. For step 2, we are going to draw our number line. And this time we only have one point to put on it, and that is that x is equal to 5. Now we need to find the value of f prime to the left and right of 5. Let's go ahead and highlight this because that's what we have to look at. Notice that that is a function that is squared, so it is always positive. So we're going to have a positive value for f prime to the left and a positive value to the right. So our function is increasing and increasing. One thing we have to keep in mind though, at 5, the derivative is equal to 0, so the function has a horizontal tangent and is not increasing there. So for our answer for part 3, we have to say that our function is increasing on -infinity to 5 and from 5 to infinity. And we have to leave out the 0.5. Here's our answer then. And before we go on to the next problem, let's look at our graph over here on the right. This is our critical point when x is equal to 5. You can see that there is a horizontal tangent there. And then to the left and right of that point, our function is increasing. In this next example, we are given a graph of y is equal to the derivative of f. And we want to find on what intervals is f of x increasing or decreasing. Since this is a graph of f prime, we can see where the critical values are. They're going to be at 1, at 3, and at 6, because that's where our derivative is equal to 0. Now we need to find the value of f prime to the left and right of these critical points. Let's go ahead and let's make a graph here, and let's put x on it. And then let's go ahead and put our points. We have 1, we have 3, and we have 6. And we are looking at the value of f prime. To the left of 1, f prime is positive. Between 1 and 3, f prime is negative because it lies below the x-axis. And then you can see the pattern. Between 3 and 6, it lies above the x-axis, so it is positive. And then for points greater than 6, it is negative. So we can see that our function is going to be increasing, then decreasing, then increasing, then decreasing. We can then say that our function is increasing on the intervals from -infinity to 1 and 3 to 6, and it is going to be decreasing on the intervals from 1 to 3 and 6 to infinity. And those are our answers.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.